Hello and welcome to our next series of lectures. So, now we are going to talk about searching and sorting techniques. So, let's talk about the searching techniques first. So, what are the searching techniques? Searching techniques or searching algorithms are the most efficient way to find an element in a list of elements. So, for example, if you want to search a place in the Google Maps, or if you want to find a person's name or phone number from a huge record or from a huge database or from a files, then you need the searching algorithms. We can search one by one, but that is going to take a lot of time. So there are efficient searching algorithms which can guarantee a list amount of time to invest and to find the particular item that we are trying to find most efficiently. So let's talk about some searching algorithms such as linear search, binary search, jump search, Fibonacci search, DFS, BFS, and some more. So stay tuned in our next couple of videos. It will be interesting. Hello and welcome to our next video. So now we are going to talk about what is a linear search. So linear search is the most basic form of a searching algorithm. Okay, so linear search is used to search an element by comparing each and every element present in the list of elements. So let's say I want to search a number in an array. So I have an array. So in this array, there are some numbers which are randomly distributed. So it's not a sorted array. So I have these many numbers and I want to search a particular number, let's say 62. So linear search says that you can search the number by comparing starting from the first element in the array, and you have to continue within a loop that searching procedure by comparing each and every element until and unless you find that number. So it will, in this particular case, it will keep on searching until it reaches this position. So if I give the indexes like 0, 1, 2, 3, 4, 5, so it will find the element in the fourth position and it will return the index. Okay, so in linear search or any kind of search, we generally says yes, it is found, and what is the index if you are working on an array. So how to write that? So let's write the code. So I have already created one folder and I named it searching, and inside that I have created linear.js. So what I can do, I can create a function and I can say linear search, and inside the search I will pass the array, and I also pass the number to search. Okay, so these two elements you can pass. So now what I'm going to do, for let I equals to 0, I is less than array dot length. So it will keep on searching the entire array. Sorry, there's a typing mistake. So let I equals to 0, and then you have I plus plus. And in this loop, what it is going to do, it will keep on comparing. So if array of I equals to target, the target that I'm trying to find, then return that particular index. Or if it does not find the number, if the number is not present in that array, then it will return -1. That's it. So let's take an array, and in the array let's write some random numbers. Let's say 12, 65, 71, 32, 47, 8, 90. And let's say I will write variable is present linear search array and I'll pass the number that I am trying to search. So if is present not equals to -1 means I have found it. So I will write element found at index position is present. So is present is actually having the index value where the element is found if it is found, and if it is not found, then it will be like element not found, element not found. That's it. So we need to call the number. So what is the number? So the number also, you can create a variable constant num equals to, let's say I am searching for 47. So now if I run this code, so I'll go to searching and then node linear search. So it is telling that the element found at index position 4. So it is 0, 1, 2, 3, 4. Awesome. If I try to find a number which is not present, let's say -22 or 222. So what it will say? Say element not found. Okay. So it is that much simple. Hello and welcome to our next searching algorithm, which is a binary search. So binary search is obviously a better algorithm than linear search because it works better when the input size, the size of the input list is very big. So let's understand what is a binary search. First of all, there is one criteria for the binary search to apply, and that is the input array must be sorted. Okay. So it can be sorted in an ascending order or a descending order. Let's consider in our situation, it is sorted in an ascending order. If the array is not sorted in an ascending order, then we need to first sort it. Then we pass it as an input to the algorithm. Otherwise, our binary search algorithm is not going to work. Okay. So how it works, let's understand. Let's take a sorted array. So let's say I have numbers like 1, 7, 15, 25, 36, 47. And I want to search, let's say 36. So how does binary search works? So let's take one more element. Let's say the another one is 65. So we need to do a couple of things. So first of all, we need to find the middle element. So we need to find the middle element in this input array. So if you can see, 25 is the middle element. Why? Because there are exactly 3 elements on the left and there is exactly 3 elements on the right. So we can say 25 is the middle. So there is a formula to find the middle. Not necessarily every input array has uneven numbers, right? So here we have 7 elements. It can be 8 elements. So if there are 8 elements, how to find the middle element? So there is a formula. So we will apply that in the actual code. Now, once you find the middle element, you need to divide the array into 3 parts, to 3 sub-arrays. Let's say, if I don't remember the numbers, let's say I rewrite the array again. 1, 7, 15, 25, 47, 58, 65. So I'm not sure whether I have written the correct, but okay, so this is middle, right?
So what it does, once we find the middle, we divide the input array into three parts. One is a left sub array, one is a right sub array. Left sub array is these three elements, right sub array is these three elements, and middle is this just the only one element, and the array is sorted. So now what we have to do, we need to check. Okay, so let's say we want to find an element, let's say 58. We are trying to find 58. This is our search element, right? This is our search element. So how can I find search element? So in linear search, what we were doing, we were checking every element and comparing it with the search element. Yes, then find, no, move on. Yes, find, no, move on. Like that. Here we are not going to do that. What we are going to do, first we will check if the search element, if search element is equals to middle. Is 58 equals to 25? Yes or no? It's no, right? So now we will go to the next else if block, and we will say, we will check that our search element can be bigger than middle element or it can be less than middle element, right? Because the array is sorted. So our element can be either bigger if it is present, and or it can be less than. If it is less than, then we no need to search these three elements. If it is less than that, we definitely don't need to search these last three elements, because obviously if it is present, it will be present on the left subarray. And if it is bigger than that, then we don't need to search this left elements along with the middle, because if it is present, it will be present on the right subarray. So our search array, the array from where we are going to search our search item, is constantly decreasing every time, right? So now we are sure that our search item is on the right subarray. So now what we are going to do, we will apply the same process. Again, we will divide it into three parts. This is middle, okay. This is left subarray. This is right subarray. So here each and every array has only one elements, but that is okay. That is possible. So now we will again do the repeat the same thing. If our search item is equals to middle, yes, it is middle. So return the index. If it is not, if it is bigger than the middle, go to the right. If it is less than the middle, go to the left. So this process will continue forever. So we can apply the process of recursion, as I have already discussed this in recursion. In recursive way, we can do it again and again and again and again. So hopefully you understand the concept. So let's start writing the code. So I've already created a file, binary.js. So what I'm going to do, I'll create a function. So I say recursive binary search, and I will pass the array, the target that I want to find, the start and the end. So we will see each and everything, what is start, what is end. So start and end are basically nothing but the starting index and ending index of the input array. So if my array has 7 elements, so it starts with 0 and ends with 6. Why do I need it? Because I need to find the middle element. That's why I need the start and end. So if start is greater than end, it means that I don't actually have a valid array. Means there is nothing. So it will return nothing, the program will stop. Else, what I will do, I will find the middle element. What is the middle element? So the middle element is math.floor. There is a formula. So it will find it by start plus end by 2. So if the array has 8 elements, okay, let's say the array has 8 elements. Or let's say the array has 4 elements, let's say 1, 5, 7, 9. So this is 0, 1, 2, 3. So in this case, how to find the middle element? So the middle element will be starting index 0 plus end index 3. divided by 2, and it is the math.floor of, means take the lower value in case of a fractional number. So this is 1.5, so we will take math.floor of 1.5 is 1. So 0 1, so this is the middle element. If there are 5 elements, then 0 1 2 3 4, so here we will have 4, so that is 2 by 2, so it will be 2, right? So 0 1 2, so then 7 will be the middle element. So the formula is pretty easy, right? So it's a typing mistake, floor, and once I get the middle element, then I will check if array of middle equals to target. As I said, if the middle element itself is the target, itself is the element that I am trying to find, then return the index of the middle element. Else, if array of middle is greater than target, then we will recursively search on the right side. So return recursive binary search array target. So I will just change the start and the end. So it will be start and mid -1. So what it is saying is array of middle is greater than target, means the target is less than array of middle. So if it is less than the middle, it will search on the left side. So that's when it will start from the beginning and go to the mid -1, means in that case, see, now this is the middle, so it will start from this is start, and this is mid -1, right? So it will search in this many elements. If it is bigger than the middle, so it will start from mid +1 to end, right? Else return array target mid +1 and end, right? So that's the main function of the recursive binary search. So let's apply with an array. Let's say I have an array which is sorted. If it is not sorted, then you have to sort it. But anyway, I'll take a sorted array. Okay. And if it is not sorted, what I'm going to do, array equals to array.sort, and variable is present, just like the previous code is present, equals to recursive binary search array get 0 array dot length -1. So it will check in the entire array from the first index to the last index, and if is present is less than 0, then console.log can say element not found, else console.log element found at index is present. So now we do not have target, right? When I'm calling the function, I do not have target. Target equals to, let's say it is 45. Okay, this one I want to find. Okay, so I have made a mistake here. This is a comparison, so I need to give double equals or triple equals. So let's say if I get the correct answer now, yeah, so now it is giving me exactly a correct answer. So it is 0 1 2 3 4. Okay, so hopefully you understand the process. If not, please send me an email and we can have a one-to-one session. Thanks for watching. Thanks very much. See you soon in the next video.